Okay, we're live.
Hello.
Hey, Sharon. How's it going?
Good. How are you, Ricardo?
Excellent. Okay, yeah. So, I think it's about time to get started with some housekeeping. Hey, Rich. Dina.
How are you doing?
Hello. Cool.
Okay, yeah. Let's do it.
Okay, so we'll just quickly step through some of the housekeeping rules that we have today. So we do have 2 sessions and we have our lovely presenters here with us.
Yeah.
Or not say nothing special today.
I'm getting feedback, so I don't know is everybody else getting that, but yeah, so if you have any questions, you can write them into the YouTube chat. If you want to see our code of conduct, we have the link in here. So it's just dev-party.io/code-of-conduct. So all the code of conduct is there. On social media, we would love for you guys to hype it up. So hashtag GDG DevParty and hashtag CloudNextExtended would be awesome. And we may also have a lovely prize to give away for the best questions at the very end. So after this session on this track, both tracks will be coming here and we will be doing our dev side chat. So we'll answer any of the questions that are in the comment section. In that, we'll have all 4 speakers today in the dev side chat. So we will have a lovely group of people to answer any of your questions.
Yeah, that's right. And in terms of the schedule, we'll have 2 tracks. The first track will be our track. We'll be with Rich in a minute. 6:15. He's gonna give a little bit of a talk of making small talk with serverless. Pretty exciting, Rich. We're looking forward to that one. And also, if you would like to jump into the dialogue flow chat, we also have the track 2. It's hosted with our fellow hosts, and yeah, that's with Guillermo Kellos, Dialog Flow to Infinity and Beyond. So we have our guest, Rich Rose. Yeah, he will start his chat at 6:15. But yeah, we would like to kind of ask a little bit of questions. He's a Google Cloud Lab architect. So Rich, if you want to jump in and unmute yourself, and we'll have a few questions of about you. We would like to get to know you, and yeah, we're all of us excited to know what you're up to these days. Hey, Rich.
Hello. Hopefully that's coming through loud and clear.
Yeah, it is.
So as it says, he's probably stealing my thunder from the slide deck, but never mind. So my talk will be just a nice introduction into serverless on Google Cloud. As Ricardo said, I'm a lab architect at Google Cloud. I predominantly work on building learning experiences for different technologies. So my 2 favorite things in the world, Kubernetes and serverless. So if you have any questions around that, please feel free to ask. Beyond that, I'm looking forward to the presentation. Hopefully you get lots out of it. There will be some code available. And nice. Fingers crossed the demo goes to plan as well. So that will always be exciting. But yeah, sure. Looking forward to it and see what's happening next.
Yeah, sure, definitely. Now that we have some code as well, we can get our hands dirty as well. Looking at the call. If you have any GitHub links, we can then share that as well with everyone. So yeah, will be nice. And yeah, so I think we just have to wait a little bit, 9 minutes, and yeah, we're looking forward to seeing your talk. Okay. Awesome.
Yeah, so I think to fill the time, here on the dev parties, we always love pulling out the googly facts from people. So I love the giggles when we say this. So, Rich, if you want to start with your googly fact about yourself.
Thanks for coming to me first.
You're so welcome.
Googly fact. Actually, googly fact related to this audience is I actually started GDG Leeds, the location, not the overall thing. So one of my first things was learning about Android way back in the day. And I used to travel across to Manchester to go to an event there. And then after I'd met the leadership of GDG for the UK, they said, well, why don't you just make one in Leeds and then you can have your events there and save yourself some travel. The obvious thing to do. So that was my googly fact. I a long time ago created the GDG.
That's awesome. And you've definitely done a lot of talks since then. We had you in Athlone GDG, probably around this time last year, a little bit earlier.
Yeah.
Full night of pizza and beer.
That yes. It's not supposed
in true Athlone GDG style.
we have certain perks of doing a talk, and that was certainly one of them. But it was a lovely talk and session. So thanks for making me so welcome.
Anytime. We were chatting to Dave, who's on the other stream at the moment now, and he was definitely saying we need to get you back to Athlone and Galway soon.
Always happy to come.
Dina, do you have a lovely googly fact for us?
Well, it's not, anything about software engineering, but I teach fitness classes to other Googlers.
Oh, that's fun.
Yeah. So I used to teach body pump and spin, and I even created my own fitness class, which was called Dina's Booty Bootcamp.
Oh, so, wow. A few of us could definitely sign up to that.
Why am I learning about this just now?
Yeah, I guess.
Dina, you're in San Fran, is it?
Yeah, I'm in San Francisco. Well, I work in San Francisco. I live in Oakland, and I used to work in San Bruno. And I've been to 15 offices, and it is my goal to go eat lunch in every office. If we're ever allowed to go back, yeah.
That's a good point.
Yeah, okay. Yeah, so I guess we have to wait a little bit longer, but we have 5 minutes. So I guess we heard a lot about Rich, but we didn't introduce Dina. I know that we will have our time with you, Dina, next. And the next hour, I think it's 6:40. We'll start the next talk. But yeah, we'll have more to discuss there. And yeah, so by now I think we could just hang around and wait a little bit, 5 minutes to see what Rich has to show us. Pretty exciting.
While you're waiting, all right, let me just jump in here. So Dina has the coolest job. She's a DPE. I'm not going to steal your thunder, but hopefully you're going to explain what that is. But it is the best job.
Yeah, I can explain it now. It's developer programs engineer. We're engineers in DevRel, and developer relations, and we are like the first users of all the new APIs and products and services, and then we build applications and write code to, first of all, to kind of test out some of these new things, and then also to show and demonstrate how to use them properly for external engineers and developers so that they can learn how to use our products. And it's one of the great things is you're just constantly in this state of learning. And I'm currently trying to learn Tecton, and that is going. Well, I'll say it's going great. Learning is it's a humbling process, is just a constant state of being faced with a challenge, being reminded like there's a lot you don't know, but then the triumph of conquering it is really wonderful.
So what is like, for example, one of those products that you learned a lot and then it went out, you kind of contributed to that? You have some examples on one of those?
Well, I worked on Cloud Run a lot when it was still in beta. I've only been in this role for, I guess it's almost a year now. Time goes so weird.
Yeah. Tell me about it. Yeah.
Yeah. So, and then Secret Manager would be another one. So, and then like all the different kinds of like bells and whistles around, like Cloud Build would be another one. And so I like to make really silly applications for my own examples. Right now, I'm working on something showing like networking and privacy settings and controls between different serverless products. And what I've built is an application where you're voting on what flavor lollipop we should make next in this this imaginary world where I own a lollipop company, and the flavors are kale, margarita, and watermelon.
Okay.
But, it goes to an ingress-egress controlled function, and then that writes to a private IP Cloud SQL instance. So it's a really silly example of the architecture that you would use for something a lot more sensitive than lollipop flavors.
Yeah, I think it's a nice example of what you can achieve with all of the new technologies that we have available. So yeah, I think that's nice. Well, yeah, I think it's almost a minute now, and we'll see. I think we might maybe start and give some room for Rich to get started and pick everything up with his talk. So yeah, okay.
Perfect. Rich, I think, do you want us to stay in the stream with you just so you have somebody to talk to, or would you like us to disappear?
Yeah, please stay on. I will be lost in my slides anyway, and then when it gets to the demo part, I will be frantically typing away on my brand new keyboard, which is very clacky.
Oh,
very satisfying.
Nice! I love those. They're great in big, busy offices when that was a thing.
Yeah, nice headphones to go cover up the
exactly.
sound.
Okay. Yeah. So yeah, we'll be back with Dina later. Looking forward to her talk as well. And yeah, cool. We'll get you back later, Dina. Thanks. Okay.
So
we'll go pop you
on.
Yeah. You got.
And then if I just make that a bit bigger.
Yeah, this looks nice.
Awesome. I think we're in luck.
All yours then.
Okay. So if I do too many tabs. Okay. Sweet. Okay. So this talk, for those of you who just joined, let me just recap. My name is Rich Rose. So thanks very much for attending this session. This is a walkthrough of a series of exercises I created, which illustrate how to get started on serverless with Google Cloud. So similar to as Dina was mentioning, one of the nice things about working at Google and pretty much any technology companies, you get to play with all the toys. So what I've done here is start to walk through the process of playing with the toys. In this instance, cloud functions. So a bit about me. So I am a lab architect at Google Cloud based out of London. My primary focus is building cloud-related training. So if you take courses on places like Coursera or Pluralsight relating to Google Cloud, you're no doubt working on some of the things that I've been involved in. A lot of the things that I like to teach over the course of time are really infrastructure related things. So lots and lots of Kubernetes. I absolutely love Kubernetes. Lots and lots of serverless stuff. I love serverless stuff. Lots and lots of networky type things and building small utilities to demonstrate particular things in terms of how they work or interact with different services. And that's always really, really important in terms of the cloud, because having worked on a local machine and you get used to building an application in a particular way, and then you have to do the transition to the cloud, sometimes it can be less clear how that works. So I'm always keen to demonstrate the best practices in terms of how to do that, or how to leap ahead and show how things can actually be done. I should also mention, because I always forget this, I am also the author of a book, Hands-on Serverless Computing with Google Cloud. This basically takes you through the fundamentals of using serverless on Google Cloud. And to that end, what is serverless on Google Cloud? So Google Cloud Serverless, essentially 3 main options. First of which is around App Engine. So App Engine, you'll see used for lots and lots of web apps. It's a really cool, interesting, hassle-free way to get your application into the cloud. It basically does all the heavy lifting for you. So it makes your life super, super easy if you use that. Scales automatically, does rollbacks, roll forwards, all that good stuff. The next option is Cloud Functions. And this list is chronological. I haven't meant it in that way, but it's chronological. So Cloud Functions gives you access to event-driven functions. And by that, we're essentially saying something happens, I want a piece of code to run when that thing happens. So if you think about if you have a web-based application, and in your web-based application, you might want to invoke an API of some description. So give me your name or tell me what the weather's like in a particular area. Then Cloud Functions is really, really great for that. So the endpoint that you're building, Cloud Functions tend to be very, very lightweight, so do one thing really well. Talk to that and then send back some information in a format. The third option is Cloud Run. Again, Dina mentioned that. Cloud Run is amazing. So if you are in the position where you like Kubernetes, you'll be sold on it. If you're someone who likes Docker, you'll be sold on it. If you're someone who likes things nice and easy and they're packaged, so you don't have to think about how things interact and all the complexities of trying to get something to work, you'll love it. Cloud Run is easily one of my favorite tools on Google Cloud. Close tie between Cloud Run, Cloud Build. Cloud Build, awesome. If you forget to use it, try it out. It saves you hours of work. So that's the background of serverless. And over the next 20 odd minutes, we're going to build an application from scratch. Well, not completely from scratch, because that would be crazy. So we're going to take some code and we're going to build it over that period of time. And the code itself is going to be really, really straightforward. And I promise you it will be really, really straightforward. So we're going to take a nice web app, which hopefully everybody's familiar with, and then add some adjustments onto it and make it so that you can talk to a back end, which is hosted in the cloud. So what does our application look like? So our application will essentially be 2 components. We're going to have a front end, which is based on HTML, CSS, and JavaScript. So typical web app. nothing fancy in there. And then we're going to have a back end. And the back end is going to be created using cloud functions. So the back end will then split into two elements. So firstly, we're going to have a Google API call, which is going to use text translations. And secondly, we're going to have another Google API call, which is going to take that text that we translated and change it into speech. Hopefully. Okay. So what does this look like? Okay. So in terms of what you're actually building, the front end runs on your local device, so your laptop or your computer. And in that, we're just going to set up a simple Node environment and run the app. If you don't like Node or don't use Node, you can use Python, Go, whatever you fancy. It's just a simple web app. Get that up and running on your machine, and that will talk to the back end. Okay, nice and easy. So let's talk a bit about the front end application. So the front end application will look something similar to this. So at the top, you've got a nice entry form which asks you for a message that you want to translate. And then the second part of the screen is the translations. So in this instance, we've got French, English, and Chinese. So at this moment in time, let's do a shout out to my daughter, Amelia, who's watching this. Yes, I included Chinese just for you. Okay, so the premise here is that what we want to do is we want to take all the hassle away from translating something to send it to the back end. I don't know whether you heard that, but my daughter just heard me going, shout out to Amelia. So yay, okay. So normally in terms of doing this, to set this up manually, quite a hassle. So we want to take the hassle out of that and show you how simple it can be. So once we've done the front end, then we can use the back end to essentially just send information back to us all the time. So a cloud function is essentially sitting there waiting. And then when you call it, it goes, hey, you want me to do something. I'm only good at this particular thing. And you say, fine, I want you to do that particular thing. So in this instance, I want you to translate this piece of text from this stated language into another language. And then it will go, right, I'll go away and do that. By the magic of the cloud, it will go away, translate it, and then come back with an answer. And that answer is the thing that you put onto the screen in terms of the translation message. So nice and simple. Okay. So we've had a look at the front end piece. Let's have a quick dive into the back end code. So to run the code, we need to introduce a Google interface. So in terms of using this, what we're going to do is we're going to use the Google Cloud user interface. And we're going to start up something called Cloud Shell. So if you're not familiar with Google Cloud, really, really simple to use. It's just basically a series of boxes and UI elements that you can press and click and ask for things. But in addition to that, it provides you with a nice interface called Cloud Shell. And Cloud Shell is basically a development machine in the cloud. So while we're thinking about that, because that in itself is a complicated prospect, let me just switch to this so we can see the correct element. And hopefully that then becomes apparent. Yay. Okay, sweet. Okay, so let me just take a step back, actually, for those of you who are not familiar with Google Cloud, because this may be helpful in terms of the discussion. So in terms of Google Cloud, when you actually go into it, there are many, many options available. So the home screen gives you an overview of your project. So Google Cloud gives you a project-based, which is essentially just what am I interested in at the moment. On the left-hand side, you get a series of options, and they're split into nice elements. So here you can see, hopefully, compute, and maybe I'll make that a bit bigger. So that's a bit better to see. Yeah. So compute, and compute has the things that you'd expect. So you have App Engine, which we mentioned earlier. You have Compute Engine, which is basically virtual machines. You have Kubernetes Engine, which is Kubernetes. You have Cloud Functions. You have Cloud Run, and you have the new VMware Engine. So I'm not even going to mention that, but that's pretty cool as well. Okay, so if we start a Cloud Function, the first thing that it's going to do is ask us to create a Cloud Function. So what we want to do here is not use the user interface, but use a Cloud Shell. So over at the top right-hand corner, there's an option that says activate Cloud Shell. And what you can do there is enable that, and it will give you a little dialog box at the bottom. So what I'm going to do is just open that up in a bigger window. Actually, I won't. I'll just drag this up, save time. So if I just go back to my slides and go to the next one. So in this one, what we're going to do, and if I feel like that has, just make that a bit bigger, I think. Okay, excellent. Okay, right, so me having multiple screens is probably not the best approach to this. So let me just make sure that that doesn't make it too small for you. So hopefully you can see that okay. Is that thumbs up that you can see that okay? Yes.
Yeah, I think it's looking good. Is it
Yep. Okay.
Yeah.
Excellent. Yeah. Okay. So what we want to do is we want to, let me just move this across.
Are you on the slides or in the, okay.
Just on the terminal window. So if that, hopefully that makes it bigger. Yes, it does. Okay. Right. So I am going to just pop out of here. So what I want to do, and I should have done this earlier, but let me just find the repo in there. And that one. So what I'm going to do is just clone a repo. So this repo is available publicly, so you'll be able to access that. It's saying it's already exists, so no cheating. Let's just remove that. Yeah, okay. Sweet. Okay. So we clone that, and then the first thing we need to do is just go into that, which is that, and we want SDP, and we want lesson 05. Okay, sweet. So in terms of the actual repo, I should mention as well, because that would be useful. If you just go back, there are actually different labs in this bootcamp. And there are different labs to take you from, I'm going to create a web application all the way through to I'm going to talk to something in the cloud. So I believe lesson 4 introduces cloud activities, and then lesson 5 adds on to that. So in this bit, we're just going to use lesson 5, and in there you'll see that we've got a back end and front end code. So the code we need is the back end, and in there we have 2 elements in there. So we've got speech and text. So what we want to do is let's just have 2 of these, shall we? 05 and speech. Okay, and then let's make this one text. Okay, winner. Yeah. Okay, so again, if you haven't used Cloud Shell before, then I just did a couple of things there which may be confusing. So let me just take a few steps back. So in Cloud Shell, once you've opened it, you basically get a terminal interface. And in that terminal interface, you can run a tool called tmux, which is a terminal multiplier. So in here, I've just basically split my screen so I can do 2 activities at the same time to save a bit of time. But don't worry about any of that because it's irrelevant to the process. It's just a nice facility that is available in the terminal. So let's just go back. Because I think previous, that one, yeah. Okay, so what I need to do is to initiate a command, you just use a gcloud command. So gcloud is the interface that allows you to talk to Google Cloud API calls. So if I do gcloud functions deploy, and we'll call it text translate. Entry, I need an entry point on API translate. With a HTTP, let's give it a region of US search for 1 and allow I believe that looks correct. Let's just try it. Okay, authorize me. Okay, good. And then if we do the same thing in the bottom one, but this time let's do let's call you API speech. La la la. And let's call you speech translate. Okay, API speech. La la la. Good. Oops. Awesome. Okay. So going back while we add lots and lots of code running in the background. So what that's doing in effect is asking Google Cloud to provision 2 cloud functions. And the cloud functions, number 1 is going to be for text translation. Cloud function number 2 is going to be for the speech API. So the first one has just finished. So that's available. So you'll notice that there is some information at the top. The bit that we need is the URL. So I'm just going to grab that quickly.
And I think, I suppose I've had a little bit of experience playing around with Google Cloud. And I think for me, with work, we would have used a lot of kubectl for all our Kubernetes work. So the only real big difference I found with the Google Cloud is just that gcloud versus kubectl. And then a lot of it is pretty much the same then after that, isn't that pretty much it?
Yeah, it tries to make it as easy as possible.
Yeah.
Oh, I have an error. In the speech API. Okay, that's not good. That is on me. Okay, so what I will do is let me just take this. So once your function's deployed, you are able to pick up the important pieces. So the important piece we need in here is this URL. So when you hit the URL, it will do a translation for you. And that's a theory anyway. So we've got that. So let me just save that into there. And then let me just see if I can quickly fix this piece of code. Actually, something. So let's have a look. Speech. So one of the things that you can do, and hopefully I have done this, is ask it to show me the logs. So I need to make this a bit bigger. And I have referenced the wrong function. Hey, well played. Okay, so let's just have a look at what it's actually called. Oh, it's called hello speech. Okay, so let's just delete that. So delete, speech translate. Yeah. Sweet. And then the entry point was hello speech. Yeah, let's just do that. Hello speech. Yep, do that. Okay, hopefully that fixed that. So if you go back to Cloud Functions, yep, that's deleting. New hello speech. Okay, so while that's doing stuff, let me just make that a bit smaller so you can see me again. We move on to the next piece, which is to try and get the local aspect. So what we've done there is just set up the backend to respond to calls from our web API. So while that's purring away, the next thing that we need to do is do a local application. So we're going to go through a similar process to the one that we did previously. And I believe I can share this. I think I can anyway. So let me just have a look. If I stop sharing now and then do reshare. Share my screen. And then do that. That is not the one I want, but I can do that instead. Awesome. Okay, so let me just do that one, get rid of that one, because that one works. Right, so, and let me just make that a lot bigger so you can actually see. Okay, so that's legible, I think. Right, so in here, I can just go into a demo folder. And we're just going to do the same process as previous. So let's just try and find my GitHub window. There it is. And then just copy that. And then what we're going to do is nothing in there. Yep. Clone that code, if I can spell that correctly. Give me that. So entirely the same process as before. I think we're an SDP, I think. Oops. Would help if I went into the right directory. And then we should have that. So we want labo 5, which is that. And now we want the front end. Okay. So in terms of the file, we've basically got a web front end, which basically kicks off a web server. But that's not the bit that we're interested in. So the bit that we're interested in is actually the application JS. And, oh, I've tidied up the code. Well played me. So the bit that I want to change is 2 things. I need from our back end, I need the URL for the function. So I go and copy that. So let me just copy this with that. So text is this URL. Okay, and then hopefully the other one is finished. Yep, so speech. Let's just trigger that just to make sure it works. Yes, it does. Okay. So I take the URL for that one and then pop that in here for the audio end. And just whack that in there like so. And the final piece is I need a storage bucket. So a storage bucket is essentially just a temporary residence for data. So in my project on Google Cloud, I have many storage buckets, and hopefully I can remember which is which. I believe it's demos, I think. Let me just check the permissions. Yes, I think it's demos. So let me just grab that. Oops, not that one. Demos.
Rich, just time check there. We're pretty much out of time there.
Oh, so you delayed me. Let me just find the actual link to this.
Yeah, we're a little bit out of time, but it's nice to also get that debugging experience that you got, and yeah, the whole setup was very nice. People in the audience like the setup with the split terminals in GCP. So
that's always pleasing to know. I'm sorry I didn't get to the end of the demo. The demo is a nice payoff, but essentially. How long have I got? Have I got 2 minutes left or none? None.
Well,
okay.
Couple seconds.
What I'll do is I'll post the video of the working application at the end because it's a nice payoff because you get to see it talking to the back end. But apologies for not being able to do that and needing to fix code in real time, which is pretty much part and parcel of any job in technology, fixing code as you go along.
And always a part of live demos.
Always.
Big part.
Always.
You will be impressed. Yeah, big part of live demos that's happened. But yeah, so it was really nice talk, and yeah, we really appreciate your
Perfect.
comments.
And Rich, you're going to hang around for the talk at the end as well, the dev side talk.
Oh yeah, definitely.
Perfect.
Yeah.
Okay, we can bring in Dina. So.
Okay, so well, Rich, we'll see you at the end, and yeah. Hey, Dina, welcome back.
Hey.
And sorry we got a little bit of your time, but yeah, hopefully we don't take any more, and let you get started then.
Yeah, I'm gonna start in just a second. I just want to say, like, breaking things and debugging it teaches you more about a product than anything else. So anyone who's watching, you probably learned more than if it had just gone smooth sailing. So that was great. Thank you so much, Rich. Okay.
Yeah, definitely. Okay.
Okay, share screen. 1 second. Application. Can you see it? Cool. Let's see if we can go. There we go. Okay, so my talk is measuring DevOps through data ops. We're going to talk about what DevOps is, what data ops is, and how we built out an open source tool to measure the performance of DevOps using data ops principles. And I am Dina. Thank you for being here. My background is in data. I spent years working as a data analyst. I've done data engineering. I've done data consulting. I've worked on machine learning projects. I've been on all the different sides of data, and I am very passionate about data, and I'm really excited to help bring actionable data insights into the world of DevOps. So let's talk about what is DevOps. Well, if you Google it, there are a lot of helpful results. DevOps is dead. DevOps is not a catalyst for cloud. DevOps is a culture. DevOps is not a role. DevOps is not a team. I guess there's a lot of things that DevOps is not. It's a little bit difficult to say what DevOps is. A lot of good possible definitions. This is the one that we are going to go with. DevOps is an organizational and cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders. In other words, in picture form, DevOps is a way of working in which we apply communication and automation to achieve velocity and reliability to make users happy. So why do we care? Why do we even, why are we even talking about DevOps right now? That brings us to DORA. DORA is the DevOps research and assessment team. It's a team of analysts who use academic methods to study how software is made and shipped, and they focus on the effectiveness at the team level. And they use a variety of statistical methods to determine relationships, like what practices and capabilities are influential in driving successful teams. And what we find is that software delivery and operational performance is key. If you want a successful team, if you want to have your software team, drive the business forward, this is what you need to be thinking about, what you need to be caring about. And so how we got there was through 6 years of research. The DORA team identified these 4 key metrics to measure the success of a software development team. And they are lead time, deployment frequency, change fail, and time to restore. And these metrics are actually predictive of success, which is a stronger relationship than correlation. And the reason why we care about these metrics is the teams that are doing well in these metrics are doing like really, really well. An elite team will deploy code 208 times more frequently than a low-performing team. Their lead time from commit to deploy is 106 times faster. And you might be thinking, hey, they're going really fast, or they go fast, break stuff. Probably they have a lot of instability, a lot of errors, a lot of downtime. Well, actually, no. the elite teams do really well in this velocity section, but also on the stability side. Their change failure rate is 7 times lower than the low performing teams. And their time to recover from incidents is 2,604 times faster. And we're not really going to go into too deeply into why that is, but if you think about it for like a little bit, if you have like an automated CI/CD system, you're always writing small pieces of code that are being unit tested and peer reviewed, and it's a lot easier to catch a bug in a very small change than it is in a very large change. If you have these like really large changes, they're more likely to break, and so that's why teams that are writing code quickly, deploying it quickly, they have these smaller chunks, and then they're able to protect against failures quickly. And since they're always rolling out and they're always deploying, that means that they can roll out a fix quickly as well. So that's what DevOps is. That's why we care about it. And those are the metrics that we care about. So let's talk about data ops. Maybe you've never heard the term data ops before. It was a new one to me a few months ago, and I've spent all my time in technology pretty much working with data. And what I realized is I was doing data ops. And a lot of teams are doing data ops. It's just not a term that has gained a lot of cultural recognition yet. To me, what data ops is and why we care about it is it's a way of producing reliability, auditability, and reproducibility in your data system. And if you want to talk about like the definition of data ops, if you look on Wikipedia, it says data ops is an automated process-oriented methodology used by analytics and data teams to improve the quality and reduce the cycle time of data analytics. Now, you might notice this is pretty similar to what we just talked about with DevOps. So when we're talking about improving the quality in data ops, you can think about that as reliability. We want to ensure that when somebody runs a query or looks at a dashboard, the data is there and it is correct. Reduce the cycle of time, that is increasing velocity. So if you need to add a new dimension to your table, that should be not like a gargantuan effort. The system should be designed in such a way that it is modular and adaptable. So to me, how I like to think about data ops is treating data as a product and data processes the way that you do software development. And maybe this seems like, duh, but maybe you've never worked with data before, and you might not realize that even today, many, if not most, data professionals are pulling their data by hand, doing calculations in Excel sheets, and emailing the reports, which creates this system that is incredibly error-prone and very, very manual. And what we find is over time, especially data teams that work alongside software teams, they started looking at the desks next door and they're going, they have all of these processes and tools that help them, reduce these instances of errors, that help them go faster, that help them gain confidence in their code. Can we use some of these things? And the answer is yes. And that is what data ops is. Data ops it's moving from this world of like Excel to automated pipelines, to peer-reviewed code, to version control, to being able to actually reproduce your results over time, and also to using unit tests. So data ops does reliability, reproducibility, and auditability, and that's why we care about data ops. So let's start talking about the 4 key metrics. This is an open source tool that we built to based on the research that the DORA team did to collect and compute and display the 4 key metrics. So these are, again, their lead time, deployment frequency, change fail, and time to restore. Approaching this from a data ops perspective is a little bit different than approaching it from like the academic research that they did. Rather than looking at surveys and doing these statistical methods, what we want is the real data. We want the systems level data, and we want all of these things to be computed automatically. And we want single source of truth. We want a dashboard that people can look to and refer to, and they can look over time, and they can check their progress over time. We want to take out the gut feelings, and we want to also take out the instances for bias and also for mistakes. And the great thing is that you already have the data. We just need to transform it. So here is the design for our 4 keys infrastructure. The main challenge that we had when starting to think about this project is that developers use many different kinds of tools and environments to do their work. So how do we capture all of them? How do we account for unknown data sources? And the solution that we came up with was to create a generalized pipeline that takes in events via webhooks and then ingests them into BigQuery. Known data sources can easily be categorized. Known data sources are parsed correctly, and unknown data sources can be categorized by the developer via an edit of the SQL script. And here is our high-level kind of data model here. We have this raw events table, which is the table that all of the events are streaming into from the webhook. And from that, downstream, we have these dimensional tables where we're starting to collect these events and creating these portraits of what I'm calling a developmental object. So we have changes, deployments, and incidents. And I'm gonna go in and just talk a little bit about some of the design decisions and the schemas. So the events raw table needed to be flexible enough to accept data about an event. It needed to be able to handle multiple events about a single object, and it should not contain duplicates. This is the table that everything else is coming from. And since it's accepting data from, the world, it's entirely possible that the source could send the same event multiple times. And we need to make sure that if there are multiple events about a single object, for instance, like a pull request, is opened, there's comments on it, and then eventually, it's merged or it's closed or something like that, that we have each of those as their own individual row. Okay, so here's the schema. We have the source, which will be something like GitLab, GitHub, Cloud Build, whatever system that you're using that the data is coming from. The event type, and this is also pulled, the vast majority of these fields are pulled from the event. So if the data model coming in from the webhook has a category or something that says type or event type or something like that, we just pull that directly in and try to do as little data mapping as possible at this stage. And so that'll be like a push or a pull request, or I think in GitLab, when the CI/CD is called pipeline event, so that would show up as a pipeline event here. And then the ID is not the primary key of this table. It is the primary key of the dimensional downstream tables. This is the ID that is coming from the sources. So if you have a bug ID in GitLab or GitHub, an issue ID in GitLab or GitHub, that would be the ID here. Also, since you're using different kinds of sources, this is, you're probably developing in a very distributed system. These IDs could be the same. Like you could have a pull request ID that is the same as an issue ID in another system. And so that's why that's not the primary key here. And metadata is just the entire body of the event. We want to take in all the data that we could possibly need. Time created is the time the event was created, and the signature is the unique key for this table. It's a hash of the entire event. Okay, so deployments is the first of our derived tables. This is updated daily via a BigQuery scheduled query, and the transformation is done entirely in SQL, making it easy to update. So when we're thinking about deployments, we need to consider that each row should be a successful deployment. This is what we're using for our metrics, and the metrics really care about successful deployments. So each row should be a successful deployment. Each deployment should have a list of all the changes associated with that deployment. Schema is pretty straightforward. You have the deploy ID, which is the ID of the deployment. The changes is the list of the IDs associated with the deployment, which we need because we're going to join it back to the changes table to get some of these time deltas. And time created is the time the deployment was complete. So I think one of the really interesting things about the deployments table and all of the derived tables is that they are materialized nightly via a SQL script, a scheduled query. And this makes it really easy to update because your business logic is gonna change. It just is. And right now, for instance, maybe you consider a successful deployment as you rolled it out to 80% traffic. Maybe there's like a big outage or something that hits a really important customer, but it was only at 20% traffic. You can, rest assured that somebody's going to come knocking on your door and say, hey, we need to start looking at deployments at 20% traffic because this caused this giant outage and your metrics say we're doing great, but like clearly we didn't do great. So your business logic will change, and that is why we want it to be easy to update and maintain this table so that, we were talking about data ops before, that's velocity. We want this to you should be able to go in and just edit the filter and say, hey, now rather than looking at traffic at 80%, we were looking at 20. So changes is the next derived table. So straightforward query from the events raw table, just a list of all the changes. So we have the change ID, time created, and the change type. Maybe you only want to include commits. Maybe you want to include commits and merge requests. Maybe you also want to include configuration changes in the infrastructure. This is a derived table, so you can adjust what is included in the changes via the SQL script. Incidents can be difficult to collect. Ideally, we would use some kind of incident management system that has the ability to send data to our webhook and to our pub subtopic. At the very least, at minimum, you need to be able to say which deployments created an incident, and then when was it resolved. So here we have our incident ID, which is the ID of the failure incident. Again, this is coming from the source table from the environment that created the incident. So like if you're using GitHub, that would be like the GitHub issue ID. The changes will be a list of change IDs that caused the failure. Time created would be the minimum deployment timestamp. And time resolved is the time the incident was resolved. So now that we have the data, we can start calculating the metrics. And it's really, really important to very clearly define what your metrics are, because a lot of people will say things that sound straightforward, but when you actually start digging down into it, it starts to become quite complex. So deployment frequency is how often does an organization successfully release to production? It's probably the easiest of the metrics to collect and calculate because it only requires the one table. If you're using something like Cloud Build, you already have all the data that you need. We just need to stream it into the table and use it to calculate frequency. So where that gets interesting is, what does it mean to deploy daily? Do you have to actually have a deploy every single day? Over the past month, what if you deployed 29 out of 30 days? What about weekends? What does daily mean? What does weekly mean? What does monthly mean? These are these buckets that the Dora team created to categorize the elite, high, medium, and low performing teams. So there's all of this research, this really rigorous research that backs up these metrics and these categories. But when you come down to the data, you have to start making decisions. It's not just based on someone saying, yeah, we deploy daily. For us, for the design that we did, a daily deployment, to say that you deploy daily, you need to, on average, over the past 3 months, have deployed a minimum of 3 days a week. And so that means, like, usually on any given work day, you are deploying, and that is daily deployment. Okay, so now we come to the lead time to change, which is the amount of time it takes a commit to get into production. So it requires 2 important pieces of data, our deployments and our changes. So you need to know when the commit happened and when the deploy happened. And for every deployment, you need to maintain the list of all the changes that were included in that deployment. And that's done really easily if you're using some kind of like CI/CD system with triggers that have like the SHA that triggered it. And so you can use that SHA to map back to the commits. And so then we join these together. We find the median lead time using the diff between the timestamps. And then we output this into these metrics, to these buckets, which are less than a day, less than a week, a month, a year. Less than a week is medium. And so we're showing it with a yellow badge here. The next metric is the change fail rate. It's the percentage of deployments causing a failure in production. To measure the change fail rate, we need to know 2 things. How many deployments were attempted and how many resulted in a failure in production. So to get this number, we need our total count of deployments. Easy. We can just look at our deployments table. But we also need to link it to incidents. And incidents could be coming from bugs. They could be coming from like labels on like GitHub issues. Maybe you have like a Google form that writes to a spreadsheet that ingests into a database or something, or maybe you have like an actual fully fledged issue management system, which would be ideal. The only requirement is that you need to link the ID of the deployment to the ID of the incident. So the next one is time to restore, which is defined as how long does it take an organization to recover from a failure in production. To measure the time to restore, we need to know when the incident was created and when it was resolved. The time it was created would be the time of the deployment, which included the failure, and then the resolution would be the deployment of the fix. So similar to the last metric, that data will come from any of the issue management systems. And we have, less than a day, less than a week, less than a month. And those are the buckets for the Dora metrics. And less than a week is medium performance, so yellow badge. So just a reminder, this is the structure of the 4 keys pipeline. We have our events, that's just, where the work was happening. And then that is going down to, PubSub, BigQuery, drive tables, into our dashboard. So this is what the dashboard looks like. I'm gonna jump in and start talking about like some of the data ops principles that were important in this design. So one is this concept of abstractions. So if you want to have good software delivery velocity, you need to have good abstractions. Code maintainability really relies on the abstractions. Otherwise, you're going to be like recreating this idea of, you know, changes every time that you want to run a query. And I've seen teams that, you know, have less mature data systems, and perhaps they have like a table that is users, and they're joining together like 7 different tables rather than creating this one table that is users. And every time they run a query, they join together these 7 different tables. And the result of it is that it's really highly unlikely that 2 people running these kinds of queries are going to get the same results. So then you'll have 2 VPs who think they're looking at the same metric, but they're getting different results. And that causes a lot of problems. But if you have a good model and you have good abstractions and you separate out these different objects, then you're able to improve reliability and maintainability and velocity. So the next thing is the single source of truth. This almost depends on your users. So like for the analyst, your single source of truth are the tables. So like the raw events table will be the single source of truth here. For the end user, that would be the dashboard. What you want to avoid is having people have lots and lots of copies of these tables or dashboards or reports, because they're going to, you know, this is like what you see when you start like forking software. You start to see many copies with idiosyncratic differences. And one of the issues there is that if there's a bug found in one, if you have a single source of truth, you can fix it and it grows resilient over time. It's stress tested. Whereas when you have lots and lots of copies of the queries, I can guarantee the bugs will not be fixed. And what you have is a system that is highly unreliable, and you end up reporting data that is very difficult to audit as well. So when somebody comes back to you in a month and says, oh, you know, we released this metric to the press and now a senator wants to know where we got it, it's going to be very difficult to reproduce that metric. Whereas when you have the single source of truth, you can have confidence that when you run it now, when you run the query in a month, it's always going to be the same, which is, you know, the whole point. Velocity, maintainability, your business logic will change, you'll find bugs. You want it to be easy to contribute and update and move fast. Okay, so documentation, I just took you through basically a verbal session of all the documentation, but it's really important because you need to know why the decisions that went into the design were made, and you also need to know what the fields actually mean and what the metrics mean. I was on a team, I left for a couple of years, and then I came back, and we kept using this metric, and it had the same name. But what happened while I was gone was the definition of it had changed without anybody knowing that had changed. And so when I was comparing what I remember to like the current state of the world, they weren't the same thing, but there wasn't any documentation on it. And so it required a lot of deep diving and investigation to figure out why these things did not align. So, you know, documentation, data definitions, even if you think like it's obvious, like time created is not obvious. It sounds obvious, but it's really not. There's no field in any table that's going to be obvious. So maybe it seems like a waste of time, but it actually is really helpful. And automation, availability. If you do nothing else, use version control, peer reviews, and unit tests. We put it into a GitHub repo, and that gave us version control, peer reviews, and unit tests. And that is measuring DevOps with data ops principles.
Awesome. Thank you. I mean, that was perfect timing. We just jumped into, yeah, good timing then. Amazing. I'm mind blown. I think I learned a lot today with it. Yeah. Okay. Yeah. Okay. Nice. So we're gonna start with the next session. It's supposed to be starting 7:15. We're gonna have a couple the fire chat, answer the questions, and with the other tracks as well. Everyone will be joining soon. Hello, everyone.
Hello, guys.
Hello.
Stephanie, Shalke.
Hi.
Hey, Ricardo.
Hey.
Hey, guys.
Okay, we're gonna put us all together. Nice.
Nice view.
How was your talks in the other track? Nice.
You're great. Yeah.
Very good, I guess. I think so.
Okay. Yeah. Because the time is we want to learn more. We want to keep hearing the speakers, but yeah, we always end up running out of time. But yeah. Okay. Okay.
Super.
Awesome.
So I think if we just start with some of the questions from the tracks, I wonder, I hope somebody has the questions from track 2, but we can start with the track 1 questions anyway and see how we get on. So Rich, the first questions are for you, and I know you've written back to some of them, but I suppose for the wider audience, we can jump in and get there.
How to do that.
Perfect. So we have the first question. I know you've answered it in the chat, but what is serverless code? Does it mean the cloud is responsible for executing the code dynamically or allocating the resources?
In this context, it's basically that what we're doing is we're looking to be responsible as a developer. We're looking to be responsible for our code, and we don't want to be responsible for the infrastructure that it lives on. So in this area, serverless is basically saying, I care about code and code only. If I want to send stuff to a nice compute resource somewhere else, that's all good, but someone else is going to take responsibility for that. So in this instance, the serverless is saying, you write your code, man. I'll look after the infrastructure. We don't even need to talk. So it's that typical DevOps thing. Never talk. Just send me stuff and I'll do it. Maybe I've diverged there.
We also have... No, that's perfect. I think it answers the question anyway. We also have another question from NJ on the serverless code. How are users billed? So is it based on the API requests to the application or the amount of processing power the code needs? Any limits on the CPU and memory for serverless?
Yeah. So I think there are a couple of points in that question, if I'm reading it correctly. So in terms of billing, there's a really handy utility called the Google Cloud Pricing Calculator. So you can see effectively how much anything is going to cost if you want to spin up any particular resources. The wonderful thing about serverless in particular is that you've effectively got quite a generous free tier associated with that. So if you just want to dip your toes and find out how it works, you can do most of the stuff that you want to do for free. And that's free, going forward, not free for, I'm going to give you 6 months or 3 months or whatever it is. So that's quite nice. The second part of that, in terms of the resource constraints, again, depending on which fully managed solution you go for in terms of App Engine, Cloud Run, or Cloud Functions, they all have different tiers allocated to them. In terms of Cloud Functions, I think it goes 256, 512, and then I think there's a meg above that in terms of memory consumption. But it's all very well documented. I can just link you through to those details.
Perfect. Thanks, Rich. We also have 2 questions for Dina here as well. So the first one is, the agile process model focuses on making developers and development efficient. So in which part of DevOps helps us? Is it only in the continuous integration, or this approach does more than we think of that?
I feel like agile is more about like development and like making changes, whereas DevOps is the entire system. So like they're not at odds. Like you can have a DevOps system that also does agile. DevOps includes the all the the deployments and like the operations, that like the managing of the application.
Perfect. We also have a question here. If one of the field names in the event for the raw schema cannot find the source data or is empty, will it throw an error or does it create and assign a default?
It should throw an error. So I tried to design it so that you wouldn't lose any data and that we could have confidence on that the data has been validated and it looks the way we expect it to look, so that when we run our queries downstream, that they include all the fields and all of the rows that we want them to include. And so what happens is it goes into the event handler, which is a webhook, and then that pushes it to PubSub. And then once it's in PubSub, it goes to these little Cloud Run workers that do like the actual transformation and inserts them into BigQuery. So at that stage, when it's trying to do the transformation, if it's looking for something and it's not there, the application's going to go, hey, this isn't here. I tried to pull this field from this dict and it's just like not there. That will, cause a 500. But the nice thing there is that data came through PubSub, so PubSub can handle the retries. And also, when you set up PubSub, you can set it up to retain your messages for a certain period of time. So you can look at the error. Maybe you look at it and you say, oh, actually, I don't actually care about this data anyway. This is junk data. That's why it didn't work. Or you can look at it and say, hey, this is this new kind of event that's coming in. And then you would update the code to be able to parse that properly and then replay the messages in PubSub.
Perfect. Awesome. We have one last question that's after jumping in now. So it's, why do you think organizations are wary of Agile and DevOps methods?
It's hard to get people to change their ways. And the idea of moving fast is, I think, a little bit scary for a lot of people because you lose control. You're afraid that, if you don't have this big change advisory board that's checking every single change, if there is a big error, like you think like, oh, maybe we could have stopped this if we had just put up more friction and more roadblocks. But what the research actually shows is that reducing those friction, reducing those roadblocks, increasing velocity helps maintain the stability because you're putting systems in place that allow you to do the first, and those go hand in hand with improving stability. So I think it's, people are afraid of change, and then also people are afraid of things breaking.
Perfect. Yeah, and I definitely agree with that. I see it in the area I work as well, especially about people afraid of change, and that it's definitely a fun barrier to break down when you move into Agile and DevOps. Okay, thanks a million to Rich and Dina. I think we're going to move over to the track 2 questions now. So Xander, can you take that over?
Yep, sure. So first up, question for Stephanie. Is there any government level or any other common standard level guidelines for data center security currently?
Other level regulations across global level or just regional, do you mean? Does that person mean?
There's a question from Tibin. I don't know if Tibin, you're on this on this
Sorry,
stream.
can you repeat the question?
Yeah, no problem. It is there any government level or any other common standard level guidelines for data center security currently?
Oh yeah, absolutely. Well, there were some of them listed on the slide that I had showed earlier, but there are, over 45, and some of them are regional. As I mentioned, there were a bunch in the UK that and the EU that were regional, of course, specifically, let's say like Spain versus France. But GDPR, and then there are a lot for healthcare in the US for HIPAA that cover a full vertical or industry specifically. And the difficult thing about that is that they constantly update and change those regulations every year, meaning that we need to address any updates to our data center infrastructure operations each year. But the one differentiator I would say about our data center security operations as opposed to, let's say, AWS, is that we don't have, let's say, a government specific cloud that you would purchase your services under. Rather, we attempt to service and orient our security measures across our entire platform so that we can meet regulatory compliance for all of those regional and global regulations. That way that you can just purchase services for Google Cloud in general and still meet your regulatory compliance needs, no matter what region you're a part of.
Cool, thank you. And I think there's one other question from the other track. At a small, from Danish, at a small organization, the managing and creation of conversation seems to work fine. Consider we have a huge number of entrants and conversations. It would be able to nice of them too. So I'm guessing that's one for you, Guilherme. In terms of having that large sort of data set, how does that work?
Yeah, for my question. So, well, basically you can manage a lot of interactions, intents, and conversations using Dialogflow. Dialogflow has some two interesting features, I would say. So you have the mega agents, so you can build, let's say, different agents and then just build as one agent, so the mega agent. So you can have you can run multiple agents as a mega agent, as one single agent, basically. And also, in considering the new announcement from last week, you have the the Dialogflow CX, and you can use Flow and Page to manage them also. So currently, as a good practice, I would say, using Dialogflow CX will be a nice approach right now, especially using Flow and Page to manage all the intents, all the interactions, all the flow that you are going to build for your agent.
That's great. Thank you very much. Just checking out. I don't think there's any other questions on stream too. Yep.
Perfect. That's awesome. I suppose a big thanks to all of our speakers tonight. And just a shout out to Danish, Tibin, and Andrew, who have won our little prizes today. So if you guys wouldn't mind emailing the DevParty UK Ireland at gmail.com, you'll be able to claim your prizes there. Thanks a million, guys. It was lovely meeting you all tonight.
Thank you. Thank you for listening. Bye-bye.
Thank you all.
Thank you so much.
Thanks very much.